so number 1 says find the X and Y-intercepts. So do you guys remember how to find X and Y-intercepts? Yeah, so an X-intercept is where we're crossing the X-axis. So any point along there, like maybe we have 5, 0, right? Something like that. Which coordinate is 0? The y-coordinate, right? So in order to find an X-intercept, we're going to plug in 0 for y. Okay, so if I plug in 0 for the y value, I get 0 equals x squared minus 5x minus 6, like that. Okay, so some people have been having trouble with factoring, so maybe we'll take a day and review some factoring stuff. But I'm going to start out with x and x. And I definitely need them to multiply to be -6. So some people might say, like, oh, I'm going to need a -2 and a +3 maybe. But if you have that, do you see how there's no way that they're going to combine to be a -5? Okay, so they have to be the opposite sign. So I'm going to need 6 and 1. And I'm going to need a -6 and a +1. So that my outer and inner, this becomes -6x. And my outer is 1x. So when they add together, that's how they're becoming -5x. Does that make sense? All right, so I'm going to set each piece equal to 0. So I get x is equal to 6, and I get x is equal to -1. So what does this mean for x-intercepts? We have 6, 0, and we have -1, 0. All right, and then the y-intercept's always the easy one, because a y-intercept, as we just kind of talked about, if I'm finding a y-intercept, it's along the y-axis, and any point along the y-axis would be like 0, something. So to get a y-intercept, I plug in 0 for the x value. So plug in 0 for x. What do we get? Yeah, we get -6, right? Do you guys see how it's 0 plus 0 minus 6? So it's -6. So it's 0, -6 is our y-intercept. Okay, so you could do a little rough sketch of that. We would know it's a parabola, it's facing upwards, and we have those 3 guiding points. Okay. All right, so the next one, if I'm finding the x-intercept, again, I plug in 0 for the y. So if I plug in 0 for the y, I get 0 equals the quantity of x minus 2 times the square root of x squared minus 9. So if I set each piece equal to 0, the first piece is easy, right? We get x equals 2. What do you think we plug in for x in order to get 0 for the second part? Yeah, definitely, right? So if I have the square root of x squared minus 9 is equal to 0, I mean, you could do all the work and square both sides, get it on one side. You'd have x squared is equal to 9, which means x is equal to plus or minus 3. Okay, but sometimes you can just kind of see it. Like, don't do all that work if you can be like, oh, if I plug in 3, I get 0. Anything else work? Oh, yeah, if I plug in -3, I also get 0, right? So those are the x-intercepts, so let's write them as points. So I have 2, 0, I have 3, 0, and I have -3, 0. And then the y-intercept, if I plug in 0 for x, I get -2 times the square root of -9. So what does this mean? Yeah, there's no y-intercept, right? So we only have x-intercepts for this. It doesn't ever cross the y-axis. All right, so same idea on the next one. So x-intercept, plug in 0 for y. So I have 0 equals 4 times 3 minus the square root of x, all over x squared. So this is one big fraction that equals 0. So the only way that a fraction is equal to 0, so think about numbers, is if I have like 0 over 7, 0 over 5, right? I need the numerator to be 0. So what I tell people a lot of times is you're thinking of multiplying that over, it just goes away. Okay, so we're not worried about the denominator, we're just worried about the numerator. So we're going to have 4 times 3 minus the square root of x is equal to 0. So we can divide the 4 out, doesn't matter. So I get 3 minus the square root of x is equal to 0. So 3 equals the square root of x. So what do we plug in for x so that when we take the square root we get 3 is what we're saying. So it'd be 9, right? So you could square both sides, or you could just see that x would have to be 9. So our x-intercept is the point 9, 0. Okay, what about the y-intercept? What happens when I plug in 0 for x? So what do we write? No y-intercept, right? So we'll just say none. All right, so same idea on this. So X-intercept, plug in 0 for y. So when I plug in 0 for y, this part goes away, this part goes away, and I just get 4 equals 0. So what do we think we write for that? None. Y-intercept, plug in 0 for x. So I get 0 minus y squared plus 4 is equal to 0. So I get y squared is equal to 4. So y equals plus or minus 2. So I get 2 y-intercepts. So I have 0, 2. I plugged in 0 for x to get 2 for y. I think I took this and I added it over here. So I think I'm good. All right, and then I get 0, 2 and 0, negative 2 are my two answers. Okay, does that make sense? Pretty easy. Sometimes you'll have to like factor and so on, but it's not bad. All right, so even functions. So even functions are symmetric with respect to the y-axis. Odd functions are symmetric with respect to the origin. So let me give you a sketch of both. So the most basic even function. Do you guys know the most basic even function? Did you guys talk about this in pre-calc? What is what?
Parabola.
Yeah, parabola, like y equals x squared. Okay, not any parabola, but definitely one that's like symmetric across the y-axis. Okay, so we're going to do y equals x squared. That's an even function. Okay, so this is even. And as I said, it's going to be symmetric across the y-axis. Okay, so what that means is any point that we have, so if I have the point, like I plug in 2 and I get 4, if I plug in the opposite x value, like if I plug in negative 2, I get the same y value. So if I plug in negative 2, I still get positive 4. Okay, that's what an even function is. So sometimes you'll see the definition where we say f of x is equal to f of negative x. So we want to write that f of x is the same as f of negative x. So if I have f of 2, it's the same as f of negative 2. They have the same y value. Does that make sense? Sometimes when you see the definition, it's like, wait, what? What's happening? All right, so that's an even function. Here's an odd function. X cubed. Okay, so for this one, we say it's symmetric with respect to the origin. And when I was in high school, I had no idea what my teacher was talking about when they said symmetric with respect to the origin. I was like, what does that even mean? Okay, so symmetric with respect to the origin, let me show you using this. If I take this picture, everybody see what it looks like right now, x cubed, and I turn it 180 degrees, is it the same picture? Yep, that's symmetric with respect to the origin. It's a rotation of 180 degrees. Okay. So what it means is if I plug in, x equals 2, if I'm plugging into y equals x cubed, I get 8. But what happens when I plug in negative 2? I get negative 8, right? So this is what we call an odd function. This is an example of an odd function. And it's symmetric with respect to, so we sometimes write WRT, the origin. So that means there's a 180 degree rotation. Okay, and the way we write this one is that f of negative x, so if I plug in like negative 2, I don't get the same as f of 2. I get the opposite. I get negative f of x. Okay, so you'll see it written that way. Sometimes you'll see both negatives on the left side. So it'll be like negative f of negative x equals f of x. Okay, does that make sense? Do you guys get it? So always think about numbers, like think about 2's. What happens when I plug in 2? Do I get the same thing? Do I get opposite? Okay, so sometimes things are even, sometimes they're odd, sometimes they're neither. So one thing that Jacob said when I asked for an even function is he said, oh, it's going to be a parabola. But I said, oh, you have to be careful because not every single parabola is even. So I could have a parabola that's like over here. Is that symmetric over the y-axis? No. So it's not an even function. So think about it. If I plug in 2 and negative 2, do you guys see how you're not going to get the same value? So this one would be neither. So there's lots of things that are neither. Most things are neither, I would say. So we're going to test for symmetry and then sketch a rough graph to check. Okay. So we didn't really test for symmetry in Algebra 2, but we did kind of mention even and odd. But if you were testing for symmetry, we want to know what happens when I plug in both x and negative x. Okay, this is always hard for students. So when I tutor students, what I show them is plugging in like 2 and negative 2. Okay, think about it. If I plug in 2, what do I get? So plug in 2 for x. 1. What happens when I plug in negative 2? 1. I get the same value. Is that an even function or is it an odd function? It's an even function. Does that make sense? So the way that math textbooks and so on have you do this is they have you actually have plugging in x, which would be x squared minus 3, and then they have you plug in negative x, which if I have a negative x and I square it, it's the same as x squared minus 3. So we got the same thing. We got x squared minus 3 for both of them. Okay, that means it's an even function. So what does a rough graph of this look like? Well, it's just x squared, and it's shifted in what direction? Down 3. Do you guys remember your parent functions? I make my Algebra 2 classes do math aerobics. So some of you, only one, Jacob Mason Cup, you're the only one. Oh, Noah, you probably did math aerobics. No, I don't know. Did I have you for Algebra 2? Just pre-calc, huh? You just missed out. It's very fun. All right, so y equals 1 over x. It's fun for me watching you guys dance. All right, so 1 over x. So if I have f of x, that's just 1 over x. F of negative x is 1 over negative x, which is negative 1 over x. Isn't that the opposite of what f of x was? It's negative f of x. Do you see how that works? F of x was 1 over x. So is it even or odd? It's odd. 1 over x. Who can show me with their hands what 1 over x does? What does it look like? This is like a really good calculus function. We do a lot with 1 over x. Sean's thinking about it. So this side looks like this. It's called the reciprocal function. This side looks like this. That's 1 over x. So if you plug in a really small number, like 1 over 100, if I plug in 1 over 100, I get 1 divided by 1 over 100, which becomes 100. So like any small fraction shoots up really, really high. But if I plug in like 1 million, right, 1 over 1 million is getting closer and closer to the axis. It's almost 0. All right, so that's an odd function. So does it work with our little spinny thing? You can, oh man, that was sad. Now it's not going to work. It does work with the spinny thing, but I didn't have everything grouped. So let's try this again. Should we group it all? You could also take your notebook and you could turn it upside down. So does it work? Same function? Same function, so it's off. All right, so next one, 9x cubed minus x. So if I plug in negative x, do I get the same thing or do I get opposite? So if I have f of negative x, I get 9 times negative x cubed minus a negative x. So I get negative 9x cubed plus x. Okay, so let's see. If I pull out a negative 1, I get 9x cubed minus x. Isn't this right here, isn't that f of x? 9x cubed minus x. So it's negative 1 times f of x. So it's negative f of x. So it actually is one of them. It is odd. Okay, so we should be seeing a pattern here. Why do we think we call it even and odd? Yeah, like the exponents, right? So that last one we had 9x to the 3 minus x to the 1. Those are odd exponents. X to the 3, x to the 1. Okay, so when I raised it to the 3 or raised the 1, it became the opposite in sign. Okay, but even functions. So if I have something that looks like f of x equals 6x to the 8th minus 7x to the 6th minus x squared, I can say right away that that's an even function. Right? Think about it. When I plug in a negative number, it's to the 8th, it's to the 6th, it's to the 2nd. Right? All of those are going to become the same number. Right? So I could say even. Yeah.
If it was like x cubed minus x squared, would it be neither?
Yeah, what if it was x cubed minus x squared? That would be neither, right? Because it has both a combination of even and odd. Okay, the only ones that are weird are when you have denominators, which we're getting to, so like this. Because this one looks like it could be like odd on top, but even on the bottom, right? It's a little weird. All right, so this one, x plus 2, or the absolute value of x plus 2. So think about absolute value functions. They look like this. Do you guys know what happens when we have a plus 2 on the inside with the x? It shifts to the left 2, right? So it's going to look the same. It's still going to be that V shape. Yeah, but it doesn't work. So again, think about numbers. So if I plug in 2 and negative 2, what happens? If I plug in 2 to the function, I get 4. What happens when I plug in negative 2? I get 0. Is that the same number or opposite numbers? No. So this is one that would be neither then. So if this was just the absolute value of x, though, what would we say is the absolute value of x? It would be even, right? Okay, so the next one. So imagine plugging in 2 and negative 2. That's the trick. That's what I always tell my tutoring students. If you can plug in 2 and negative 2 and they're the same thing or opposite things, that's good to know. All right, if I plug in 2 into this function, and if you just want to do like a little t-table over here, if I plug in 2, I get 2 over 4 plus 1 is 5. If I plug in negative 2, I get negative 2 over 4 plus 1 is 5. What is it? It's odd. But that's kind of weird, isn't it? Because there's an even exponent in it. And actually the number 1 on the bottom is 1x to the 0. So if you have an odd divided by an even or an even divided by an odd, it ends up being odd. The odd wins. Yeah.
How does like the exponent thing work for the absolute value?
Yeah, it doesn't really work for absolute value, I guess. So only if it's like a polynomial or a rational function in this case. All right, so find the intersection points by hand. I don't know why it says y equals here. That drives me nuts. No y equals. I must have typed it in weird. I don't know what I did. Okay, so we're going to find the intersection points by hand. So we're going to use substitution or elimination. Hopefully you guys remember this. So these are 2 lines that are intersecting. So we want to be able to either solve for one of the variables, like get x equals or y equals, and then do substitution, or we can line them up and get rid of them. Do you guys remember that? Yeah. Okay, so what happens when I add straight down now, though? I get negative 2x, negative 3y, nothing goes away. So what do I need to do? Yeah, multiply that bottom by 2. So when we do, we get the 5x minus 6y equals 9 still. And the bottom one becomes negative 14x plus 6y equals 36. So when we add straight down, negative 6y and 6y goes away. They cancel each other out. So I get negative 9x equals 45. So x equals negative 5. And then we go back into any equation, doesn't matter. So let's say I go to 5x minus 6y equals 9. So I have 5 times negative 5 minus 6y equals 9. So I have negative 25 that I'm going to add over. So I'm going to add 25 over. Did I do this right? Did I mess something up? I just didn't make a nice one. It's not a nice one? Okay. All right, so I end up getting, yeah, which reduces a little bit. So negative 17 over 3. So our answer is negative 5, comma, negative 17 over 3. I think I took this from the book, actually. I was too lazy to actually think of one. It doesn't take long to think of a system of equations. I don't know why I just didn't do it. That's okay. Things are messy sometimes. Not every answer is nice. All right, so this next one. Do you guys know the 2 shapes that are intersecting? So what's the top shape? A circle, and it's intersecting with a line, right? So if I have a circle intersecting a line, what's the most number of answers I could have? 2, yeah. So I could have 2 answers on this one. So this is one where, notice how we have the y right here by itself? Well, not quite by itself. We can get it by itself though, right? So we get y equals 10 minus 2x. That's how I would approach these ones. Because I don't have like the x squareds where I can like line up x squareds or line up y squareds, because the second equation doesn't have an x squared or a y squared, right? So we're going to do substitution. So we're going to take the y and replace it with 10 minus 2x. So I'm just going to the top equation, and I'm taking y, and I'm putting in 10 minus 2x for it. All right, so back when I used to teach at IU, we used to grade all the midterms all together, all of us, all at once. And those of us that would get this one page in particular took us so much longer because a lot of the students got it wrong. So a lot of the freshman math students at IU did this. They said 100 minus 2x quantity squared would be, or not 100, sorry, 10 minus 2x quantity squared would be 100 minus 4x squared. Okay, you cannot do that. We used to call it the freshman dream because then they would all get A's on their math test. Okay, so what we have to do here is we have to FOIL this out. So we're going to write 10 minus 2x multiplied by 10 minus 2x. So we're going to get 100 minus, my outer is 20x, my inner is negative 20x, and my last is 4x squared. That's what's going right here. So we're going to have our x squared out front, and then we're going to have plus 100 minus 20, I'll write it out, minus 20x minus 20x plus 4x squared equals 25. Okay, so this is all coming back to you. We get everything together, so I have x squared and 4x squared, so I get 5x squared. My 20 and 20 combined to be 40, so minus 40x. And then my 100 on the left side, if I subtract the 25 over, I get not negative, positive 75. Like that. Okay, we pull out a 5, the GCF. And then we can factor, that's a 15 there. So I'm going to do x minus 5 and x minus 3. So those are my two values for x, 5 and 3. So remember, the most number of answers we can have is 2. So if I go back and plug into the x squared plus y squared equals 25, I'm going to have y squared equals a number. I'm going to take the square root. I'm going to get plus or minus. I would get 4 answers then. Okay, so whenever you plug your answers back in, plug them into the thing with the smallest degree. Okay, so this one had a degree of 2. This one doesn't. It's degree of 1, right? X to the first, y to the first. So we're going to plug back into the 2x plus y equals 10. Or, to make it easy, plug it in here. Y equals 10 minus 2x. So y is equal to 10 minus 2 times 5. So y equals 0. So that point is 5, 0. And then y is equal to 10 minus 2 times 3. So y is equal to 4. So that point is 3, 4. Okay, know what you plugged in for x, though. Because sometimes people will be like, oh, I have 5 and 0 and 5 and 4. I have 3 and 0 and 3 and 4. That doesn't make sense, right? 5 is the only thing that gave you a 0. Okay, 3 didn't give you 0. Does that make sense? Is that the last one? Okay. All right, so number 3. So we're going to talk about sketching something weird by hand. So when you see y squared minus x equals 9, I think most of you guys probably know what shape this is. Okay, it's a parabola, right? But it's not our up and down parabola. Yeah, it's a sideways parabola. So these can be a little tricky. So let's think about it. Let's get the x isolated. So I'm going to have y squared equals x plus 9. And then I'm going to subtract the 9 over. Because really, like when it's a parabola on its side, the best way to graph it is to let y be your independent variable, like that thing you're plugging in for with the t-table. So this way, now that I have it like this, I can easily pick numbers for y. Like I could pick 0, 3, negative 3, 1, -1. I can plug different things in for y to get x. Did you guys see that? So if I plug in 0 for y, I get -9. If I plug in 3 and -3, I get 0. That's kind of why I picked those. If I plug in 1 and -1, what do I get? -8. So I get -9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 3. 0, -3. -8, 1. Oops. 1 and -8, -1. So we can see the problem on its side. Okay, so don't sweat it when you see something like that and think, oh my gosh, I don't know how to graph it. We can always resort back to t-tables. Okay. Is that the last one? Yep.